Uh, Good evening, everyone. Good evening, everyone. Hasim is my name. I just want to give a brief information about the project that I want to do. I'm going to do my project on plastic deformation of I-beam. Basically, plastic deformation is called permanent deformations. This is as a result of the structures is being given a load that is much more than what it can bear. So when you apply load on any structure, be it high beam or device, anything that you apply load on it, if the stress that you are applying on the structures is more than the yield strength of the structure, so the structure will become will deform permanently. So which means if you remove the load on it, it's not going to come back to the normal shape again. That's what we mean by permanent deformations. And this is the equation that I'm going to use. I just want to verify this equation. I know the equation is right. I want to use ANSYS to verify this equation. I want to use this beam. One of the beam is going to be fixed. It's going to be a cantilever beam, and the load that I'm going to apply is going to is not going to be a constant load. As you can see, it's going to be a very load. It's not going to be a constant load. So in this case, I will model this structure inside ANSYS, and I will verify the permanent deformation and see what is going to happen. That's what my project is going to base on. My length of the beam is going to be 400 millimeter. I haven't done that in ANSYS. I have to get this type of graph. If I don't get this graph, which means my model is not correct or does not say something that we could that could be approximated to this equation. So what is the interpretation of this graph? I will let you know now. This graph from here to here is the elastic region, and from here to here is plastic region. This plastic region is what I'm very much concerned about, and we don't want this to happen to any material. We don't want this to happen to any structures, because it's a total failure. So it's a failure, and we don't want that to happen to any material. So whatever load that we are going to place on any material or any structure should not be should not be more than this place. This place is called yield strength. If the load or the stress on any structure going beyond the yield stress, the material is going to deform permanently, and that will be a total failure. As I said, the science behind this is this: when you apply load, any material that you have, there is certain arrangement of lattice or structures, or there is arrangement of atom inside any material, be it wood, metal, or any material you might talk about. There is certain arrangement of atom inside it, and that's why we have phase cubic, phase center lattice structures, center cubic, hexagonal, and different type of arrangement of atoms. So when you apply the load, the plane is going to remain in its own position. It's going to be vibrating in its own position averagely. But if the load increases beyond this point, if the stress increases beyond this point, the plane is going to shift to another position. And if you keep applying load or stress on it, the shifting of the plane is going to continue. And even though you remove the load within this region, is not going to come back to this plane again. So it will only come back to this place, and you can see from here to here it's like the same shape from here to here. So this place from here to here is plastic deformation, while from here to here is elastic deformation. So you will have permanent deformation when this plane, when the arrangement of the lattice structure in a certain plane shifted to another plane. So you will have a permanent deformation, and this is what this graph is telling us. So I have this I-beam structures from this side. This is the side I got it from, and this is the shape of the I-beam, and these are the different sizes of the I-beam with respect to their weight, width, the height, the flange, and some other thickness, and some other parameter that you can see. So I have to choose one of these enhances, I have to model one of these enhances with respect to length of 400, as I said, and I will do my simulation on that enhances. So this is the true stress, and this is the true strain as well. This equation, this two equation is the same thing with the one I showed you earlier on. Just that we need to prove it, we need to do some proving before we can get the one at the top. This is the true stress and true strain. We don't, so in engineering, we basically, theoretically, we use engineering stress and engineering strain, but practically, the true strain and true stress are the one that is happening practically in the material when we are applying forces like that. Just to make it easy, that's why we convert it to engineering strain when we are doing theoretical calculations, just like an approximate value. So this is the what I will get in ANSYS. So after my simulation in ANSYS, I have to get this something like this, which means I haven't applied the force. This place is fixed, and the force is applied at a very the force that is not constant from here to here. You can see the shape of the force as I show you. The force is not it's not a constant force. So if I apply my force here and the force is greater than the yield force, or the stress that I apply here is greater than the yield strength of this material, the material is going to bend, is going to deform permanently. It's not going to be straight beam again. So you can see here that this beam bends permanently, and that will be the result that we want to verify inside the ANSYS simulation. In the next of my video, I will explain how I got to this plate in ANSYS, changing parameter and some other things like that. But the only thing we can do in engineering to make sure that we don't have this type of occurrence is to apply safety factors. So safety factor will limit the maximum load that could be placed on this beam. So at the maximum load that the safety factor is going to dictate, it has to be less than the maximum load that will cause the yield strength to this material. So in that case, we are going to be within the elastic region. So we are not going to go beyond this point when we apply the safety factor. So that's what we use in engineering. Thank you very much for watching my video. I really appreciate it. I will pause this video and I will do the second video to do the ANSYS analysis so that we can see how we got to this place. Thank you once again. I really appreciate it.